What if your thoughts were no longer private? Every thought you think begins as an electrical signal inside your brain. But what if those signals could be decoded and turned into words? Scientists are now building systems that attempt exactly that. This is no longer science fiction, it is early-stage science. Your brain contains nearly 86 billion neurons, constantly communicating. Every decision, every emotion, every word starts as electrical activity. Even when you stay silent, your brain is constantly speaking in signals. These signals are invisible to the human eye, but not to machines. And that is where brain-computer interfaces come in. One of the most advanced efforts comes from companies like Neuralink. Their goal is to connect the human brain directly to computers. This could allow humans to control devices using only thought. Early experiments have already shown promising results. Simple commands can now be detected from brain activity. But reading complex thoughts is still far beyond our reach. The human brain is far more complex than any existing computer system. Yet progress in AI is accelerating this field rapidly. What once took decades is now happening in just a few years. And we are only at the beginning of this revolution. Researchers have discovered that brain signals follow recognizable patterns. These patterns can sometimes be linked to specific thoughts or intentions. In controlled environments, AI systems can already interpret basic neural activity.
But these systems are still far from understanding full human thought. The biggest challenge is not collecting data, but understanding it. Human thoughts are not simple signals. They are layered, emotional, and contextual. Even the same thought can change depending on context. This makes decoding thoughts incredibly complex. Yet progress continues at an extraordinary pace. What seemed impossible a decade ago is now becoming reality. In recent years, brain-computer interface research has moved from theory into real-world testing. Systems like Neuralink aim to create a direct communication link between brain and machine. The goal is not just communication, but restoring lost abilities. Early trials have shown that simple intentions can already be detected, but accuracy still depends heavily on training and calibration.
The brain is not a static system. It constantly changes and adapts. This phenomenon is known as neuroplasticity. It means your thoughts are always evolving, and this makes decoding them even more challenging. Despite this, researchers are getting closer to translating human intent into digital commands. As brain-computer technology advances, a critical question emerges. If machines can decode thoughts, what happens to mental privacy? Unlike spoken words, thoughts were never meant to be recorded, but future systems may change that forever. Governments and companies are already investing heavily in neural data research. This raises concerns about how brain data could be used in the future. Could thoughts one day be stored, analyzed, or even predicted? These possibilities are both fascinating and deeply controversial, because understanding the brain means understanding the self. And that is what makes this technology so powerful and so uncertain. Despite the risks, brain-computer technology could redefine human capability. It could restore communication for people who cannot speak or move. It could allow humans to interact with machines without physical input, and even expand how we learn, create, and think. But with every technological leap, responsibility becomes more important.
The challenge is not just building the technology, but guiding its use. The future of mind-machine connection is not predetermined. It will depend on the choices we make today. We are standing at the edge of a new era of intelligence. And the question is not whether AI can read the mind, but what it means if it ever truly can. Hit that subscribe button and turn on notifications if you want to stay on the cutting edge of science and tech.